Hi everyone, in this video we are going to practice drawing Lewis structures, but in order to do that properly we absolutely need to be very comfortable with starting off with Lewis symbols. So take these four elements and just draw the standard Lewis symbol for each one of these. Go. Alright, did you get an answer? Hopefully you did. All you had to do was draw in the missing valence electrons. So we're going to start with helium. All you have to do for Lewis symbols is just recall that you always put the first two dots together. So the first two dots, they go together, and then you can kind of divide or kind of add dots as you go around. Helium only has two valence electrons, so we're done with that one quite quickly. Carbon, same thing. Carbon has four valence electrons because it's in group 4. And so what we do here is we see 1, 2 valence electrons together, and then we divide them out and separate for the next two. So 1, 2, and then we have 3, 4. Okay, so we put those separate and then we go through around. All right, so let's do phosphorus now. Phosphorus has 1, 2. It's in group 5, so it needs 5 valence electrons. So we have 1, 2, 3, 4, and 5. Again, the 3, 4, and 5 are added separately. You do not double up on those until you get to the next electron. So we'll be able to see that in fluorine. So fluorine's in group 7. It's a halogen. So it has a lone pair here. So we've got 1, 2. So it needs 7 things. 1, 2, 3, 4, 5, now you double up, 6 and 7. Okay, so that is the proper Lewis symbol for fluorine. This needs to be something that you can do like that. You don't even think twice about it, that if I ask you to draw helium, you're just like, boop, boop, 2 dots. If I do nitrogen, you're 2 dots and then boom, 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 3 right around. You need to be super fast at it. All right, so now here's your chance to kind of practice some more Lewis structures. Here's 3 different examples. So you have SH2, CBr3F, and then BBr3. So draw out the proper Lewis structures for all 3 of those. Go. All right, did you get an answer? Hopefully you did, but if you didn't, that's okay. We're going to work through it together. SH2, once you see it, is going to look very, very familiar to you. But the first thing that I like to do is always remember that my Lewis structures need to be symmetrical if possible, okay? Nature likes symmetry. You think about your body, you have an eye on each side of your head, you have one nose, one ear on each side. Nature is all about symmetry. So if a molecule can be symmetrical, it's definitely going to try to be, okay? So now SH2, I'm going to put S in the center and put an H on one side and an H on the other side, right? Just try to do some symmetry here. Sulfur is in group 6, so I know it has 6 valence electrons around it. So 1, 2, 3, 4, 5, and 6, okay? So we have 6 valence electrons. Hydrogens are each in group 1, so they only have 1 valence electrons. Now I have all my valence electrons set up. I'm going to try to kind of connect my dots to see if I can start forming bonds. So here I see a single electron. I can partner that up with another electron. Same thing here, single electron can attach to another electron. So now we have a beautiful Lewis structure. If you want to, you could redraw it and just try to have something that looks maybe a little bit prettier than that, but that's basically what your Lewis structure would look like, right? All right, so let's move to the next one. Again, nature likes symmetry. So right away, you're going to try to put that carbon in the center. Carbon wants to be in the middle. If it can, it loves being the center of the attention. Stick that bad boy right in the center. So here's your carbon right there. Well, again, you can only do some symmetry. Maybe do a bromine on this side, bromine on this side, and then you have to break it up. So I guess a bromine here on the top and a fluorine here on the bottom. But just try to kind of create some somewhat of symmetrical piece. So now, add into your halogens, your valence electrons. Each of these are halogens except for your carbon, so they all want to have 7 valence electrons around them. So each one of them is going to have 3 lone pairs and then a single electron so that they can each have their 7 valence electrons. Now carbon wants to have 4 different electrons. So it has 1, 2, 3, and 4. And so I'm just kind of randomly drawing those about. Yes, I should probably draw these 1, 2, 3, and 4, but you'll see right away that it is impossible to have 4 bonds. So 1, 2, if you have something in a lone pair. So right away, just instinctively, when you put carbon in the center, you're going to learn to start breaking those electrons apart. All right, so now connect your dots. Dot to dot, dot to dot, dot to dot. Notice that I'm only drawing lines from single electrons. I'm not going into any of these lone pairs. The lone pairs are protected. Those are going to stay by themselves. You're not going to touch those and break those apart if you can, all right? Sometimes you have to, but try not to. All right, so now this is a gorgeous, beautiful structure. So let me redraw that because that's absolutely hideous. So a beautiful version of this would be a carbon that's connected to a bromine that has 7 electrons around it. Carbon's connected to another bromine with 7 electrons. It's connected to a fluorine with 7 electrons. And then this one's connected to another bromine with 7 electrons. Okay, so you have this beautiful structure, and you've finally been able to kind of create something that is, for the most part, fairly symmetrical, which is nice. All right, let's do one more, which is our BBr3. Again, try to go for symmetry. So right away, I'm going to put my boron in the center, and then I'm going to try to put my 3 bromines a little bit symmetrically around the side. Ish symmetrically, close enough, right? So now put in our electrons like we did before. Bromine is in group 7, so it's going to have 7 valence electrons. So each one of these bromines is going to have a lone pair and a single electron on it. Boron's in group 3, so it's going to have 3 valence electrons, so we can do 1, 2, and 3. Again, you could draw boron like this, the 1, 2, put this together, and then the single electron over there. But if you try to keep that together as a lone pair, you would only be able to create 1 bond, and we know right away that we need to have 3 bonds. We need to open up that lone pair for boron, okay? So that's what we're going to do here. So what we're going to do is start drawing our lines. So single electron to single electron, single to single, and single to single. And now, boom, we've got this gorgeous, beautiful Lewis structure. So we have B, Br, again, draw your electrons in, another Br, draw your electrons in, and then another Br, draw your electrons in. There's a lot of B's in that one. All right, that's your Lewis structure. You can go through and check each of these Lewis structures to obey the octet rule and your formal charge, but make sure you've actually seen that formal charge video, so don't jump ahead of yourself here. What you'll notice right away is that this boron right here actually does not obey the octet rule, but that's okay. It's not supposed to obey the octet rule, so if you're freaking out about that, please remember there's only certain ones that obey that. This boron is totally fine, okay? All right, so now I believe I have at least one more structure for you here. One more question. What is the Lewis structure of oxygen, nitrogen, and then this complex organic molecule down here? So now, easy one, hard. Oxygen and nitrogen should be something that you can just go and have it drawn out immediately. Go. All right, did you get an answer? Hopefully you did. Oxygen and nitrogen, like I said, are ones that you just need to have in your back pocket. You need to just know what those look like. So here's one oxygen, here's another oxygen. Oxygen's in group 6, so it's going to have 1, 2, 3, 4, 5, and 6 valence electrons. We can do the same thing here. 1, 2, 3, 4, 5, and 6. Draw your single electrons, so this connects. This connects. Now you have your oxygen. If you were to draw that properly and try to make it look nice and beautiful, you'd probably draw it out something like that, okay? Same thing with nitrogen. This is another one that you just need to know how to draw. Nitrogen's in group 5, so 1, 2, 3, 4, and 5 valence electrons. Same thing here. 1, 2, 3, 4, and 5 valence electrons. Now you want to connect all of your single electrons like this, and you end up with a gorgeous structure right there, which again we would redraw to have our nitrogen with a triple bond, and each nitrogen has a single lone pair. These need to be something that you can just boom do. All right, now let's get to the complicated one. When you get to something like this, if you panic, A, that's a bad thing, but B, just remember, start on your left side and work to the right and very slowly go through this. You can see that I didn't write this as C2H6. That would be a way to give you no hints on how this is structured. I told you exactly how this molecule is put together. There are 3 hydrogens on this carbon. This carbon's then attached to this carbon, and this carbon's then attached to 3 more hydrogens. So let's work through that. So carbon here, we said it's attached to another carbon there. Each of these carbons is attached to 3 different hydrogens. So 1, 2, 3. 1, 2, 3. Pretty straightforward, but if that was too fast for you, there's another way to do it. Oh, let me not show that one way. All right, so you do your carbon here, try to do symmetry. The only way to do this with symmetry is to line those 6 hydrogens around, perfectly around it, symmetrical. All right, hydrogen has 1 valence electron. In group 1. Carbon has 4, so 1, 2, 3, and 4. Same thing here. 1, 2, 3, and 4. So now you're going to draw your lines. Single bond, single bond, single bond, single bond, single bond, single bond, and single bond, all right? So if you were to draw it out and make it look nice, it would look like this, okay? So that is your 2 carbons. This is called ethane. And we'll talk about that in the future. All right, so now I've shown you how to draw that. We're going to kind of ramp it up a notch. Try this one. H2CCH2. Remember, start on the left side, move to the right. You can do this. All right, did you get an answer? Hopefully you did. Remember, start on your left side and move to the right. We see that these 2 hydrogens are on this carbon. This carbon has to be attached to this carbon, and then this carbon has 2 hydrogens attached to it. So carbon, carbon, and they each have 2 hydrogens. Let's see if we can make something kind of symmetrical. That looks kind of symmetrical. All right, draw on your electrons. Hydrogen has a valence electron because it's in group 1, while carbon has 4. So we have 1, 2, 3, and 4. 1, 2, 3, and 4. So let's draw in our lines here that are most logical. And then we're going to draw one single line here. This is usually where people stop and they go, oh my gosh, I don't know what to do because I've already drawn my single bond in, now I have a single electron. Some people will try to cross those out and put them together here as a lone pair. That's crazy. Never do that. That doesn't make any sense. The most logical explanation is do what a kindergartner would do, right? A kindergartner would just connect the dots. That's what they would do. That is absolutely the proper structure. So we would redraw this. You have a carbon-carbon double bond. It's attached to, well, each carbon is attached to 2 hydrogens. And so you have a beautiful structure that ends up with something like this, okay? Each carbon definitely obeys the octet rule. They each have a formal charge of 0. Beautiful structure. All right, let's try one more. Keep this structure in mind. Now try this one. Go. All right, did you get an answer? Hopefully you did. I am so fingers crossed hoping that you just were like, and flew right through this one. But if not, don't worry about it. Lewis structures are tricky, and depending on how your brain works, this might be something that just takes you a really long time to grasp. But I promise you, every human is capable of understanding this. You just have to put the hours in, okay? Just put it in, work, work, work. You can do this, okay? All right, so now again, start on the left side and move to the right. So we've got our carbon and our carbon. We know our hydrogen's attached to this carbon's attached to this one, and that carbon's attached to 2 fluorines. So carbon's here, carbon's here. We can kind of make it symmetrical, kind of the same structure here. We don't want to move these fluorines around because the structure is telling us that these fluorines are attached to that carbon and this hydrogen's attached to this one. So now what we're going to do is add in our electrons. We know our hydrogens are in group 1. They only have 1. Fluorine, same thing. It's been this whole video. It has 7 valence electrons because it's a halogen, so we need 7 around it. Carbon needs 4, so 1, 2, 3, and 4. Same thing here, 1, 2, 3, and 4. Now draw your lines. Hydrogens are always really easy to draw. Fluorines are always really easy to draw. It only wants 1. Now we're back to this predicament again where we can connect 1 dot and then connect 1 dot. And so we have literally the exact same structure that we did before in the last example, except for now we've just substituted out 2 of our hydrogens for fluorines. And so what I'm hoping that's starting to happen is that you're starting to see these patterns, and so you go, okay, this is the exact same structure. The only difference is that these are hydrogens, or these ones has fluorines, but it's still a carbon-carbon double bond, same type of overall structure. So I really hope this is making sense. If not, take a minute and just practice. Do as many Lewis structures as you possibly can until it makes sense and you don't make one mistake. You don't do it till you get one right. You do it until you don't make any mistakes, okay? Good luck. Practice, practice, practice. Have a great week. Take care of yourself. Drink water.